Hello and welcome to another A-Level Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on entity relationship diagrams and relational databases. Let's just take a moment to do a quick recap of the terminology we learned when we were doing the GCSE unit on databases. An entity is a type of person, object or thing about which data is stored in a database. This data for an entity will be stored in a table. A record is a single row in a database table and all the data for one entry. This can be seen here, outlined in a red box. A field is a heading under which data is stored in a database table. This is often also referred to as an attribute. A primary key is a field that uniquely identifies records in the table. In this case, ID. A foreign key is when a primary key from one table is included in another table to create a link between the two. Entity relationship models, often referred to as just ER models for short, show the relationships between data entities. A data entity is a thing we want to store data about. A database for a doctor's office might include entities like doctors, patients, rooms, equipment, and things of this nature. Entities can be related in three ways: one-to-one, one-to-many, and many-to-many. When trying to work out a relationship between two entities, consider it separately from each end. The relationship between a student and a report card, for instance. A student will have just one report card. Any one report card will belong to just one student. Therefore, we have a one-to-one relationship. If we look at a form group and students, one form group will contain many students, but any one student will only have one form group. Therefore, we have a one-to-many relationship. When we consider teachers and students, one teacher will have many students, and one student will have many teachers. Therefore, we have a many-to-many relationship. Entity descriptions are written in the format of entity name, followed by all of the attributes that make up that entity, written inside brackets. An attribute or attributes that make up the primary key are underlined in the entity description. So for a teacher in a music school, there might be a table to store personal details or the instruments taught. So the entity for the teachers table might look something like teachers, and in brackets, teacher ID, underlined as the primary key, forename, surname, phone, and email as the other attributes. Or instruments, with instrument ID as the primary key, and instrument and type as the other attributes. In a relational database, each entity is a separate table in the database. Tables are linked by using foreign keys. A foreign key is the primary key of one table used in another table. So if each of our music teachers teaches only one instrument, the link can be made by adding an instrument ID field to the teachers table. This creates a link between the teacher and the instrument that they actually teach. In our last example, one teacher taught one instrument, but any one instrument may have been taught by many teachers, so there was a one-to-many relationship. Many-to-many relationships can't be linked in the same way. To overcome this problem, we use linking tables. A linking table will have a composite primary key made up of the two foreign keys from the tables being linked. So in our example, we introduce an instrument teachers table. Now, we will have one teacher can appear many times in the instrument teachers table if they teach many instruments, and one instrument can appear many times in the table if there are many teachers of it. But we only have to implement one-to-many relationships, which we know how to do. Let's have a look at another scenario. This time we'll consider a library. The library will have many members that want to loan many books. So what we need is some sort of link table, a loans table that has member ID and the book's ISBN as its composite primary key. Fields like loan date and due date that are not dependent on either member or book individually, but depend on the actual loan, which requires both member ID and ISBN number, will be able to go in this link table as well. That brings us to the end of this video on ER diagrams and relational databases. Join me again soon when I'll be back with another video on normalization of databases. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.